Okay. Alright, so to finish this last part, this one's tricky. That's why I'm going to do this. I was going to just leave this for you, but check this out. It says sine x equals cosine of the double angle. Okay, so right here. So, like, unlike this first one over here, this one's going to be a lot more confusing because right now I'm dealing with two different terms, okay? Like, this is a sine, this is a cosine, but this is cosine of the double angle. So it's just weird. Like, if I move it over to the other side, it's like that's fine, but things are just strange. So I'm going to look real quick at my formula sheet what cosine of the double angle is. Cosine of the double angle is everything right here. So it's equivalent to either cosine squared minus sine squared, or you could rearrange it and make it worth 2 cosine squared minus 1, or it could be 1 minus 2 sine squared. Now, I like this one right here, and the reason why I like this one right here is because this one has a sine in it. And if I go back to my equation, if I had another sign, that'd be okay. Okay? So I'm going to use the formula that if this is cosine of the double angle, it's equivalent to 1 minus 2 sine squared of the angle. Okay? Let me just double check that I wrote that down right. Was that plus or minus? Oh, it was minus. Okay. So here it is. So that means I can replace this portion with this portion. Does that make sense? Because this right now is this. So that means I can interchange it with this side, okay? So watch, I'm going to go ahead and write that down. Sine x, that's that, is equal to 1 minus 2 sine squared x, okay? So I see that it's got a square, so that's going to be a quadratic, okay? So I'm going to move it over to one side, everything over to one side, and then I'm going to solve it like a quadratic, just like part B. Okay? So watch. If I move this over, then this is going to be 2 sine squared x, and then the sine x is still going to be there. It's positive. And then this 1's going to move over as being negative 1, and then nothing's going to be left over here, and I'll just be left with 0. Okay? So now it's a quadratic, and it looks a lot like this. Let's put it into terms that we're familiar with. Let's say that it's 2x squared plus x minus 1 equals 0. See, now it's not so bad. Okay, so looking at this, I'm going to just use the x. So what are factors of negative 2? That'll give me 1. That'll be positive 2 and negative 1. Divide by our a term, which is 2. So that equals 1. So now these factors are going to be x plus 1. And then this one's going to be 2x minus 1 equals 0. So I'm just going to replace the x with a sign. So sine x plus 1, and then this one is 2 sine x minus 1 equals 0. Alright, so now I'm just going to solve it. So this one, when I set it equal to 0 and subtract the 1, this one's going to be sine x equals negative 1. This one over here, when I add the 1 and then divide by the 2, that's going to be positive 1 half. Okay, so this is going to be sine x equals positive 1 half. Okay, now we just look where this is true. Okay, what's the angle that gives me negative 1 for the sine? So I look at my chart. Where's negative 1 for sine? It's at 270 degrees. So then that's going to be 3 pi over 2. That's this one. Okay, now where's sine positive 1 half? Sine is positive 1 half at 30 degrees, which is pi over 6. And then also at, where else is it? 1 half. 5 pi? 5 pi over 6. Okay, so that one's also 5 pi over 6. Okay, so these are all, that's going to be a big space in between, but these are all our values that are the solution for part C. Okay? Alright, so let's continue on. Let's finish these last, well, at least to 34, because these ones are easy. So in order to convert 36 degrees into radians, we need the radians. So we're going to multiply by pi over 180. Okay? And then down here, to convert to degrees, you're going to multiply times 180 over pi, because the pi has to eliminate. So that's all you got to do. You just got to try this out, okay? So if I multiply 36 times pi over 180, does 36 go into 180? Anybody have a calculator? It goes in 5 times? Yeah? Okay, so 36 goes into 180 5 times. So then this is equivalent to pi divided by 5. That's how you would do that into radians. Okay? So I would say try this one. Multiply this by pi over 180 and see what you get. And then let's try number 34. 34, in order for us to get rid of the pi, to convert it to degrees, we're going to keep the pi in the denominator because it has to cancel out. And then the 180 goes like this. All right, so the pi's cancel. Now, I know 6 is in 12. So if I said this is 2 times 6, 6 goes into 18. 6 goes into 18 3 times. And then 2 goes into 30 15 times. And then I have 5 times 15. What's 5 times 15? No. 75? Think 75 degrees. Okay? Yeah, that's 5 and then 2, 75 degrees. All right. So that's how you do that one. I would say try this one on your own because you need that practice. All right.